Welcome to 1.6 Engineering Disciplines. Now that you've completed the Discover Engineering assignment, I would like to go over the Big Four as well as some other fields of engineering. So, just as a reminder, engineering being the application of math and science principles to better or improve life, and engineers are using these principles to solve practical problems. The Big Four fields of engineering once again are right here: chemical, civil, electrical, and mechanical. Pretty much any college you go to that has an engineering degree is going to offer at least one of those. And then all these other fields that we're going to discuss are derived, which means come from, combined, or an extension, a specialization of one of these fields. But first, we'll talk about the big four: chemical engineering. So we can see the definition right here: applying principles of chemistry, physics, and engineering to design the operation of plants for the production of materials. And here's the thing: what you're looking at is designing the operation of plants, producing materials that undergo chemical changes during the processing. Responsible for new and improved products, so things like fuel for rockets, boosted propulsion, medicines, vaccines, serums, plastics, all that. You can think of this in a way of you could make the COVID vaccine, but you have to be able to produce it at a scale that is big enough to get it to everybody. You have to be able to manufacture it cheaply enough with those processes so that everybody can use it. So, scientists may have discovered the vaccine, chemical engineers design the operation of plants um, to make these vaccines. The next big one and a popular one is civil and construction engineering. So, supervising the construction of facilities in both the public and private sector. There are all kinds of things that civil engineers do. This is one of the biggest and widest types of engineering, but if it's a public project, a civil engineer is involved. The building that we have next door, the Career Tech Annex, had to be signed off by a civil engineer. Right? You can see all these types of projects that they do, but this is by no means inclusive. There's all types of stuff that civil engineers do. If it's used by the public, you can pretty much guarantee that a civil engineer had to do with it. And if it's a large scale building, even if it's privately owned, civil engineers were involved. Electrical and electronics engineers. So, our definition here dealing with the motion of electrons and metals. So the motion of electrons and metals is what's electricity, but they're focusing, as you can see, on large electrical systems, motors, generators, circuits, power transmission, electrical generation, all that types of things. So for instance, an electrical engineer might have designed the electrical layout, had to sign off on the electrical layout of the building, the new Career Tech Annex, but they wouldn't have been the ones actually installing it. Mechanical engineering. This is probably not probably, this is the broadest form of engineering. If you are a person that says, I would like to do engineering, but I don't know what I would like to do, mechanical engineering is the way to go. Mechanical and then probably civil. Mechanical engineers are used in almost everything because the design of machines and devices. If it moves, a mechanical engineer was probably involved. There's so much that happens in this field that it's really hard to narrow down exactly what a mechanical engineer does because there's so many different projects that they may be working on. Now, there's other engineering disciplines as well. We're going to talk about those. These are the ones that are either combined, derived from, or an extension of those big four. So you have aeronautical engineering, flight and movement of fluids in the Earth's atmosphere. So aero is Earth's atmosphere, planes, things like that. But it doesn't necessarily have to be planes, all right? Anything moving in the Earth's atmosphere could be aeronautical engineering. Aerospace, all right? There's the astronautical. That means environments not found on Earth. That's your rocket scientist. They are working for NASA. Specialization in work areas centered on propulsion, all that type of stuff. Auburn actually has a great aerospace engineering program. And as a matter of fact, University of Alabama in Huntsville has another good program as well. Because of NASA being located there, they have a lot of internships that are involved with NASA. Agricultural engineering. So you're looking at engineering systems, but also soil, land management, and environmental control. You can see that there are these specialty areas that you may be involved in with agricultural engineering. As you can imagine, Auburn was actually originally an agricultural college, and so they have a fairly extensive field here. There's architectural engineering. Now, this is a subset of civil engineering and also related to structural engineering. But here's the big deal. The main difference in architectural engineering and structural or civil is the concern for the aesthetics, aka how it looks. Making sure that it's not just structurally sound and stable, but that it looks good as well. There's a lot of study that goes into this one because architects have a lot more schooling than you might think, and then you have to combine that with engineering as well. You have automotive. All right. Now, engine design, structural, tire, all that. Automotive involves basically all of the big four. Mechanical and electrical are probably the two biggest parts of automotive engineering. And there's a big field for that around here with the Kia plant in West Point. There's a Mercedes plant in Alabama. And actually, a lot of cars are built around here, so there's a big need for automotive engineers. Biomedical engineering. You're taking engineering, physical sciences, and life sciences. These are all coming together as one to solve medical and health related problems. Now, notice that there's three general divisions, and each of these are biomedical engineering, but they are very differently in what they do. So, let's start with bioengineering. Right here, you are looking at biological processes. How can you engineer, I don't know, genetic engineering, all types of things, but how can you modify those? You have medical engineering, so within the actual medical field, okay, that can encompass all types of things, but medical devices, prosthetic stuff like that. And then you have clinical engineering. Clinical engineering involves actual, say, doctor's offices. Um, Maybe you are involved in the engineering of something that goes within patient and doctor use, MRI machines, things like that, something that's used in clinical or actual medical visits. Then you have computer engineering, so the design and organization. And there's actually two very, very different types. There's the hardware and the software. So hardware engineering, you can think of this as computer parts. All right. Now, a good example of what happens here is Intel and their processors, all right, that run all the computers. They actually go on kind of a back and forth cycle. One year they make the processor faster, then the next year they take the faster processor and make it smaller. The year after that they make it faster. And engineers are involved in the actual hardware or the components of computers. Then you have software engineers. All right, those are the people that are developing operating systems, coding systems, things like that. Now, that doesn't necessarily mean that as a software engineer, you're not sitting there and just programming video games. What you're doing is developing, say, the Unreal Engine that video games are programmed in. And then my big fun fact is the largest consumer of computers today is actually the automotive industry. Cars today have at least a dozen computers each within them. And it's very important to be able to use those computers to maintain things such as fuel ratios, engine timing. Brakes are actually computer controlled as well. So it used to be that brakes had an actual brake line that ran directly to the brake pedal, and then but now if that goes out, there's a computer module that actually sits between the brake pedal and the brakes themselves that tells the brake system how much pressure to apply to give you more control over the brakes. There's industrial engineering. So you're looking here at design, improvement, installation of this system of people, materials, and energies to ultimately produce a product at the lowest possible cost. Think about it this way. You're looking at systems for the manufacturing of products. You're looking at assembly lines. You're looking at factories, okay? You're looking at things such as the machinery that goes at the very end of the machine of the assembly line or specific parts to analyzing an entire manufacturing process, all types of things involved in the manufacturing of materials. And the final one that I'd like to go over is manufacturing engineering. Now, as you can imagine, this one is related pretty closely to what we just talked about. And with manufacturing engineering, in this situation, you're also looking at the designing of an entire manufacturing facility and parts of it. So, how do you lay out the plant? How do you design the factory line to give you the most efficient use of your time? Do you need to use existing machines? Do you need new machines? Once again, you're looking here, looking at purchasing facilities, purchasing equipment. Do you retire equipment? How is it packaged? How is it shipped? All those type of things. This type of stuff as well is also going to be explored in the third year computer integrated manufacturing class. But that is our overview of different engineering disciplines. Don't consider this a final list of the only types of engineering there are. There's other things out there like materials engineering that's based entirely within material properties and how they can be manipulated. There are so many different categories of civil engineering. There are some super specialized categories. There's all types of things out there. So, in this next assignment, y'all are going to research a STEM career that you're interested in. So, don't think you have to be limited to just what is shown here.